All right, people, we're going round 2 here for section 2.4 for proofs. As we did here, we proved this one and I talked about a possibility of going a different route. There's always more than one way to do a proof and showing your justifications or your reasons. Okay, so I asked you to work on this one and we can talk about it in class if anybody has any questions. Let's go down here to this scenario. And look at all the work is done for you, and to solve for x, we just have to be able to provide all the reasons or proof of what we did. So if that be the case, let's look at our first equation here, our original one, and see what they did here that's different than what we did here. And I'm noticing that we have the parentheses here are now gone, and now we have a 3x minus 6 plus 4. So I'm going to say that this is the distributive property. Okay, and then we went here from 10x minus 3, 3x minus 6 to plus 4 to 3x minus 2. So I'm going to say they took this part right here and they combined it. So we're going to say simplify, and that we did combine in like terms. Okay, then we look here and all of a sudden it goes from 10 minus 3x to 10 minus 6x. So I'm assuming, and then we only have a negative 2 here, so I'm going to assume that we did this, I'm going to put in here, we minus 3x to both sides, so we did the subtraction. I'm just shortening things up here, prop of equality. So we did subtraction, and that's how we got to this point. And then we went from 10 minus 6x to just negative 6x equals negative 12. So we're going to be, again, subtracting 10 from both sides. So we're just going to use the subtraction property of equality. Okay, and then the last thing, going from negative 6x equals negative 12 to just x equals 12. So I'm going to say that we divided both sides by 6. So we're going to go the division prop of equality on that one. Okay, so that's how we did that. So now I want you to do the same thing, but on the next example, it's asking you to do both the math on the left-hand side and given the reasons on the right side. It looks like there's about 5 steps for you on that one. Okay. All right. So go ahead and take care of that, and we can talk about it in class if you have any questions about it. Let's go ahead and go to the next page, and I'm assuming we're going to look at this one as well. It says to prove. So I want you to do that one on your own as well. So again, write the equation in here and find out that we want the final answer, we want u to equal 6. Therefore, give our reasons and find out if that's actually true or not, and go from there. Now, interesting thing is, now we're going down to geometric proofs. I'm going to show this here, but before I do that, I'm going to bring up the book, and it's going to talk about how we do this because it has this word up here, postulates, in this scenario. So I'm going to, let me move my stuff out of the way here to help you out. Okay, so here we go. So this one's a little bit more in color and interesting compared to what the black and white version is of yours in the book. But a postulate or an axiom is a statement that is accepted as true without proof. Okay, so it's important to know that. Basic ideas about points, lines, and planes can be stated as postulates. So here we go. So we're going to go through some of these postulates and axioms as we see here. So we're going to call this postulate 2.1. Through any 2 points, there is exactly one line. So 2 points given a line. Okay, and there's line N, or we can name it as line PR or RP. Okay. postulate number 2.2. Through any three non-collinear points, there is exactly one plane. Again, non-collinear means that they do not all lie on the same line. So here's the explanation. Plane K is the only plane through non-collinear points A, B, and C. Then we have postulate 2.3. Gotta move this up just a little bit here so we have a little more room. A line that contains at least 2 points. Okay, so that's another one that we have there. Then we have postulate 2.4. A plane contains at least 3 non-collinear points. So it's almost the exact same thing as we set up here. But notice between the difference between 2.1 and 2.3. Notice that this talks about 2 points create a line, and then this one talks about a line that is created by 2 points. So it's going backwards. Same thing with 2.2 compared to 2.4. Again, talking about non-collinear points first, creating a plane. Then we have a plane that it has at least 3 non-collinear points, so it's going backwards. So we're flipping it around. Okay, so section 2.5 or postulate 2.5, if 2 points lie in the plane, then the entire line containing those points lie in that plane. Okay. And then postulate 2.6, if 2 lines intersect, their intersection is exactly 1 point. Showing here is what we're talking about. Okay, and then 2.7 shows if 2 planes intersect, then their intersection is a line. So like the corner of the floor to the wall is where we have a line. Here, same thing with the ceiling to a wall. Again, creates a line that we can visually see. Okay, so that's from the book, and it's important that we understand what postulates are. So let's review again. A postulate is, or an axiom is a statement that is accepted as true without any proof at all. Okay. Alright, so now you have this on page 5 of your guided notes. Those all are on there, okay, and you can see that they're all located there and included. So let's go ahead and turn to the next page. Okay, so we're on page 6. Okay, now let's look at these ones. Explain how the picture illustrates that the statement is true. Points F and G determine a line. So where's F and G? Okay, so we have that there. And what does it state? What are we talking about here? So FG determine a line because 2 points contain, at least 2 points contain a line. Therefore, we can sit there and say what a postulate is this? 2 point 2.1. Okay, postulate 2.1. Now, section B, or part B. All right, points A and D. So here's A and D lie in plane B, E, C. So we know that these are non-collinear. So we're identifying this side of the building as it, and then we have these 2 points here in plane N on line N. Line N lies entirely in the plane BEC. So which postulate is that? Where we have a line that is inside of a plane, and I see that as one being a postulate 2.5. Okay, let's look at the next one. Line N and P intersect at point D. Okay, so here we go. Point D, where's it at? Is right here. Line N and P right here. Again, what postulate do we identify that one? This one is section or postulate 2.6. Okay. All right, so what I'd like you to do next is on your own, I want you to be able to identify which postulates these are related to for you, and then we can talk about them in detail. Okay. All right, now we're going to add 2 more postulates here. Postulate 2.9 and 2.11. I'm dealing with proofs. See, we're almost done here. So now all we do is that we got the segment addition postulate. So basically what we're taking is taking a line segment AB and line segment BC, and we're pretty much just adding them together to create one entire line. So it's not anything different than we've done before as far as the segment or addition the addition postulate or addition. Boy, I'm just having here the addition property of equality on this one. Same concept. And then we have the angle. So we got to move up here. Then we have the angle addition postulate, which is pretty much the same thing. We're taking two angles, and then we're going to add them up to be a total angle of ABC. So basically, again, we're doing the angle additions postulate, taking two angles, adding them up, and making them equal to there. Okay? All right, so let's go ahead and move on to the next part here. Let's look at this example that we have here. And we're looking at example here where it's talking about use a protractor. A construction worker measures the angle of a beam makes with a ceiling at 42 degrees. What is the measure of the angle of that beam that makes with the wall? Okay, so that's example number one. So what we would do is I would sit there and draw a picture. Generally, you don't have to necessarily use a protractor to figure that out. Okay, but I would sit there and think that it says use a protractor. Construction worker uses the measure of a beam that makes with the ceiling. So we're talking about a beam. That's our beam, and then this is our ceiling, you know, like in a house here that we're talking about, and we're going to call this 42 degrees. What is the measure of the angle of the beam with the wall? So what we want to know is, with the beam here, what is that going to be? Here's what they're asking for. Okay? So in most cases, we know if this is 42 degrees, and we know that the beam to the wall is usually a 90-degree angle. So I'm going to sit there and say that this is 90 degrees there. Okay. Now, same scenario here. It says find the measure of angle 1, which is right here. Okay. And then if measurement of angle 2 is 58 degrees, and we know that the whole angle is equal to 162 degrees. So we set this up as 162 equals x, we'll call 1x plus 58. And then we just use our properties that we've learned by subtracting 58 from both sides, and we get x equals, and what's that? It's going to give me, I think, 104 would be our answer. I'm guessing off the top of I didn't use my calculator for that part. Okay. All right, we're going to stop there. At this point, this is part 2, section 2 of 2.4. We have a little bit more to go over for yourself here before we go any further. Okay, let me just double check here on some of the stuff. I think we're actually going to be okay because of what we talked about here. So I'm going to stop there for today, and this we're going to call it done for today. I think we will a little further